Doo-doo, 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 doo-doo. Okay, okay. Let's go next. 2048. It's 2 to the power of 11. Right. Next greater number balanced numerically balanced number. Next greater numerically balanced number. Enter x is numerically balanced if for every digit d in the number x there are exactly d occurrences of that digit in x. Okay, so like 1 occurs once, 2 occurs twice, 3 occurs 3 times. Give an integer n, return the smallest numerically balanced number strictly greater than n. If it occurs, okay? So the next bigger one than 1 is 2, and that appears twice. And then the next biggest one from there would be like 3, 2, would be 122. The next biggest one from, yeah, maybe. 122 would be after 22. Double check. So 22. Let's kind of not compile. do 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 do. Okay, yeah, 122. And then after that might be 3. No, it'd be like 221. No, after that would be like 212. And after that would be 221. I want to say. Alright, well, let's go ahead and after 1000 is 133. 13333. Well, this certainly is not immediately easy in my mind. Interesting. 0 to 0 to 10 to the 6 is n. Alright, let's just name like the first 10 to see if I can see a pattern. So 1, 22, 122, 212, 221, 333. Interesting. Next from there would be, I think, 1333, and then 313333133331, and then 4444. At some point it needs to incorporate the 2's back in there. It'd be like 14444, and then 1 14444, 1. It'd have to be 2's next, I think, because I don't think there's another one bigger than all 4's in the hundreds place or thousands place. I think it'd be like 1 or 2, 2, 3, 3, 3. Yeah, and then like maybe 2, 3, 2, 3, 3, 2, 3, 3, 2, 3, 2, 3, 3, 3, 2. Yeah, I think all those are correct. So it looks like maybe the last one of a certain number of a certain length is going to be all of that, all will be digits that are the same repeating of the length. So 22 is the biggest 2-digit. 333 is the biggest 3-digit. All 4 is the biggest 4-digit. And then there would be some combination of previous digits, somehow possibly up to that length if possible. So if the length is 1, then there's only 1. If the length is 2, then there's only 2 2s. If the length is 3, then technically it could be like 1 2 2 and some combination of that in all 3s. Length is 4, that's like some combination of 1 and 3 3s for all 4s. Length is 5 would be 1 all 4s, 2 2s, 3 3s, and all 5s. Now technically the 1 all 4s occurs once, and then it'll be some combination of the 2s and 3s, and then after that would be like combinations where it starts with 4 1 4 4 4 4 4 1 4 4. So something where it starts with 40,000. Length is 6, it'd be 1 and 5 5s, 2 2s and 4s. Can't have 3s, because then there's no other complement to that. Okay. Smallest numerically balanced number strictly greater than n. Interesting. So if I take a random number, let's say the number is like 30,000, 31,415. So I first analyze that this is 5 digits. And 5 digits means it's going to be some combination of 1 4s, 2 3s, or all 5s. If it's bigger than repeat of length, let's say, I don't know, let's say n is the length of the number. If it's bigger than the repeating of n, like n times, or n digits times n, like so, in this case example would be 5555 because the n is 5, then it should be this, then return smallest of next. So that'd be like 1 and all 6s. 1 plus n plus 1, or the digit that is n plus 1 times n. No. All 5s. No, yeah, times n. Yep. 1 and 5 5s at that point. Smallest of n plus 1 digits. Okay, so that solves most cases, I'd want to say, a fair amount of cases. And here it only goes up to 10 to the 6, so I don't really have to worry much more than that. So the question is for something that is more less non-trivial. So like 31415, 31415. Yeah, I wonder if I can generate the whole list. How many numbers are actually going to be there? Seriously, how many numbers are going to be there? It's like This is a very finite set of numbers. Like seriously, it's the answers are going to be 1. Okay, so 1 digit is 1. I don't know how to do the spacing in Python. Fuck. 1 2 2 2 1 2 2 2 1 10 to the 6. Is that 100,000? Is that a million? Oh my god, I'm so bad at million. Oh, I mean it's just 6 digits, right? 2 2 1 3 3 3 1 3 3 3. I mean, yeah, I guess this is reasonable to actually write it all out. 3 1 3 3 3 3 3 3 1. Oops, 3 3 1 3. How do you do? I keep on forgetting. How to format new line in Python code. How to indent. How to indent. Python automatically handles continuation within parentheses, brackets, and break lines within these constructs without explicitly continuing. Indent the subsequent line to align them logically with the opening delimiter. Okay, opening delimiter. So I think they expect me to do this. Opening delimiter is this one. I don't think I should be tabbing. Okay, I think it's like that. Okay. 4 4 4 and then 1 4 4 4 4 1 2 3 4 2 2s and 3s 2 2 3 2 3 3 2 3 3 2 3 2 3 3 3 2 4 1s 4 4 1 4 4 4 4 1 4 4 4 4 4 1 all 5s. Actually, maybe this was not the most reasonable way of doing this. Kind of committed now. Actually, I mean, this is 6 digits, right? 2 4 2 4 4 4 2 4 4 2 4 4 2 3 4s 2 4 2 all 4s and a 2 5 1s 4 5s 5 5 1 3 5s 5 5 5 1 2 5s 5 5 5 1 5 and all 5s and a 1 6 6 6 6 6. The devil ending. I think that's it. This 10 to the 6. And I guess, yeah, I guess I need one more in case it's bigger than that. Okay. While n index, while n is less than answers at index increments, return answers at index. I think maybe this should be less than or equal to. N is 1. Yeah, less than or equal to. List index out of range. That shouldn't be possible. This is pretty darn big. What's going on? Actually, this might be too big. While n is less than or equal to index. Oh, actually, whoops, I think this is reverse. While n is greater than answers at index, greater than or equal to. Greater than or equal to. Okay. Oh boy. Oh my god, I forgot a whole subset of answers. I'm missing the ones that start with 3. 3, 2, 2, all 3s, or remaining 3s. 3, 3, 2, 2, 3, 3, 3, 3, 2, 2. I think that's it. Although the 2s should be separated, possibly. Which does seem to imply that I'm forgetting some answers. Yeah, I'm missing answers that are like starting with 4s here as well. Oh boy. This is getting quite troublesome. Somewhat regretting my tactic. Okay, I mean, 2, 2, starting with 2, separated, and then 2 in the second spot. Yeah, this should be 3, 2. Yeah, I'm missing 3, 2, 3, 2, 3, 3, 2, 3, 3, 2, and 2 in the third spot. So it'd be 3, 3, 2, 3, 2, 3, and that's it. And then 3 in the fourth spot is that. Okay. What is going on with this tabbing? I didn't finish even getting the answers. Well, at least at most there's going to be... I mean... It's not complicated enough that I wonder if I should just be trying for the non-static solution. I guess I'll just finish this and see how it plays out. Like, it's gonna be 2... I wonder if I should just do the non-static solution. Oh, The non-static solution is just more interesting. Okay, let's just try it. try to find the actual way of approaching this. So I think I first need to determine what digits I'm dealing with, possibly. Do 3000 is 31333. Okay, so let's go ahead and convert n to array of digits, maybe. Digits equals, what is this going to equal? Equals the list based on the string, n convert to a string and then made into an array of digits. So map this to integers, the string that is n, and I'll just go ahead and verify that this is syntactically correct. Gosh darn, missing closing friend. So 1, okay. Okay, I'm going to go ahead and say the length is s, sure, s is the length of n, or maybe size. Okay, so if I had size, I guess I could do an array of length 6 that is like the possible combinations that I'm dealing with. 1, 2, 1s and 2s or 3s, 1s and 3s or 4s, 1s or 4s, 2s and 3s or 5s. So maybe something like 1, 2, what am I thinking about here? Maybe it should be a tuple, an array of tuples. No, an array of 2D array tuples. So tuple here would be 1, tuple here would be 2, tuple here would be 1 and 2, or 3. Be just 1 and 3, or 4. And then 1 and 5, 2 and 3, or so no, it's 1, 4, 5, and then 1, 5, 2, 4, 6, and then last but not least it'd be like 1 and 7, 1 and 6. Yeah. Let's go ahead and just go for every p impossible. Just making sure this is correctly happening like I think it should be. Oh my god, what did I do? Oh jeez. Return 0. Size equals length of digits. Yeah, it's too close. Oh my gosh. Huh. So having a tuple, having a list of just one tuple seems like it. Interesting. So it doesn't actually, maybe it automatically converts tuples of one value to just that value. I guess that makes sense. Maybe. Not really. But I guess it's definitely automatic whatever it's doing there. Well, I see. It's treating it as a parentheses. Okay. Python. One value tuple. Guess maybe I need to have tup. Yes, parentheses. This creates a singleton tuple. Okay. Yeah, I kind of want it to be a considered tuple. Guess now I have somewhat of a realization of when I've seen the syntax before and was confused by it. Kind of confused by why I had it, but now seems somewhat obvious or more obvious. Okay, so 1, 2, 3, 4, 5, 6. Does that help? So if I look at my digits, if I look at the length of the digits, then I access that index minus 1 or use the length minus 1 as the index into the possible 2D array. That'll get me the digits, the possible digit combinations to construct the next value. The possible digit combinations to construct the next value. And then what? And then maybe I construct the next value using each tuple possibility, and then just use the lowest of those possibilities as the overall. That wouldn't be too bad, actually. Okay. So for each p, let's say tuple combo in the possibility at this size minus 1, okay, I'll say low is equal to infinity, because I'm going to keep track of the low. So the top combo has the digits that I'm going to be using for the number. So there's going to be at most 2, but there could be 1. Okay, so let's say if Okay. I think maybe construction is not what I want to do for this one. So I mean, like, I could do something where I have a repeating digit multiplied, so I can create an array where like have the repeating digit like 2 times 2 and get a 2-digit array that's 2 2, and then convert that into a string and then convert that back to an integer. But that's just barbaric. I'm just going to use index into a stack array. So if the length of this tup combo is 1, which means it's a singleton, then I'm going to do the value is equal to repeats at this top combo, repeats top combo 0. There's only one value in there, so if it's a 1, minus 1, use that as the index. Else, and then I need to do a more complicated version, and then I say low equals low. No, low is not correct actually. Low equals infinity. It's just not correct. What am I trying for? It's the lowest thing that's still above n. I guess maybe I can do if, after this, if the value is greater than n and value is lower than the current low. I guess that should be an inequality, a double inequality, or compound inequality. If n is between the value, which is also less than low, then low equals this value. And then after the loop, it should be something like if the after the loop, it should just return the low. And maybe before the loop, it needs to do something where it's bigger than the repeating value. If n is bigger than repeats of the size minus 1, then I need to return the call this the next low. So the next low is from 1 digit, it can be 2 digits, which is 2. Next lowest from 2 digits will be 3 digits of 122, 133, 1 4s, 1 5s, 1 6s, and this should be return next low of size minus 1. So if the size is 1 and n is like 3, so 3 is bigger than 1, repeats at 0. So it needs to return next low of 1 digit, which is 2 digits, which is going to be 22. I think that's right. And if it's not one of those trivial cases, I guess this should be less than or equal to. If not one of those trivial cases, then I'm going to do construction. Okay, so in the construction, this is this singleton tuple, and then this should be the non-singleton tuple. So let's say A, B equals the 2 digits in the tuple combo at this point. And and let's say frequency of A and frequency of B should be A and B. I need to track how many times I've used it. So and then what? So then what? 3,000. So like at this point, it should be something where, let's say I'm dealing with 3,000, which is 4 digits. 4 digits is going to have 1, 3, or no, actually, that's too simple. Well, no, maybe it's not. So it's 3000. So it's going to have a top combo that's 1, 3. So I need to somehow create a number based on that thing with 1s and 3s, if possible. If possible. So maybe I need to have a current value. And here I'm just going to go I guess I'll just use the lowest one if possible and default to using the biggest one if not. So something like I guess I should start with place value. Place value should be initially the number of digits, which is size. So size is going to be 4, which is going to be 10 to the 1, 2, 3. 1, 2, 3, 4. So size is equal to the place power of the 10. So I'm going to use the smaller one if possible. So if frequency of A not equal to 0 and using the A digit in this spot is possible. And let's say current plus A times 10 to the power of place value is greater than the n. I think that's right. Greater than, and it needs to be greater than, not greater than or equal to. So if I'm using a smaller one, it's not quite right. Because if n is like, let's say 1000, and the answer would be like 1333, I'm starting with 1. Starting with 1 is correct even if it doesn't seem like it's big enough. 1000, or if let's say n is like 1001, right? Correct answer to be still be 1333. So I want to use the smallest digit that still makes it better, makes it bigger. Wonder if I can let's consider the number of digits in n thus far. Then I might be cutting it too close. So what if I saw that it's a 3000? Frequency of A, frequency of B. 3,000. So if it's it's 1,000 and let's say 1,500, then technically 1,3,3,3,3 or 1,3,3,3 doesn't work. So we need to have a 5, or we need to have 3 starting. So it'd be 3,1,3,3. Just doesn't work. Doesn't work. Do. Wonder if I can do the biggest remaining. If I had a 1, biggest remaining would be 333. And so anything that's the number digits so far plus the biggest remaining is still less than n, then I did something wrong. Oh my god. Oh, the static solution would have been so much simpler. Okay, focus, focus, focus. Numerically balanced. Tell you what's not mentally balanced at the moment. 3, 1, 3, 3. 3,000. If you if I started with the biggest thing, no, it just didn't work. Or so what if I started with the smallest thing and incremented? So it'd be like 1, 3, 3, 3, and somehow I figured out the next one should be like 3, 1, 3, 3, and the next one should be 3, 3, 3, 1, or 3, 3, 1, 3. But if I actually had like 2s and 4s, it'd just be really tough. I mean, kind of really tough, maybe not really tough. Ones and 5s. There are literally 6 combinations there, something like that. 2s and 4s, it'd be 6 choose 2. 15 combinations. That static answer looks pretty damn tempting. I'm not gonna lie. Alright. Let's see. I mean, this is kind of stupid in terms of like, I should test the static answer. So it should be 1, 22, 122, 212, 221. 3, 4. 4s could also have 2s and 3s, right? So, and then 2s in the first place, 2s in the first place still. And then 2s in the second place. Two in the second place. And then 2 in the third place. And that should be 5, choose 2. 10. Missing one. 2 in the first place. 2, 2. 2's in the second place. I'm missing a 2 in the third place. Whoopsie. Yeah, I'm missing one. Okay. Okay, so there's 10 there, and then there's going to be a few with 4s at the start. So that should be 5. And then there should be starting with, and then all 5s. And then the next one will be 1 and all 5s. And then it should start with 2s and 4s. So 2 in the first place. 2. Okay, now 2 in the second place. So 4, it should have to start with 4, 2. And then that, 4, 2. Missing, that's right. 4, 2. 4, 2. And then 2 in the third place, so it needs to start with 4, 4, 2. Missing. Oh, oops. 4, 4, 2, 4, 4, 2. Okay. Now it needs to be 2 in the fourth place, so it needs to start with 4, 4, 4, 2. That's it. No. Missing something. 2 in the fourth place. Oopsie. And then 2 in the fifth place. Alright, there should be 15 there. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. And then last but not least is all 6s. And then like 1 in all 6s. Oh my, okay. So I think it's like while, this goes back to the other code. Index is 0, while static's index is less than n. While n is, what was the other code? While n is greater than static's index, greater than or equal to. Okay. if what was the wrong answer I had before? Still wrong answer, really. Oh. Not my best moment. Missing a comma. Not my finest moment. Does that mean I made a mistake with the 4s as well? Yeah, I did. Not my finest moment. 4s, 5s, 6s, 7s. Okay. Yeah. I hope I didn't forget something. Oh, Jesus. Oh my god. Why am I so bad at this? Oh, fuck me. Yeah, I totally did forget about this. Oh my god. That's so many more. Oh my god. Fuck. And that means I missed out on the tuple that is 1, do 1, 5. Yeah, this thing's gonna even be worse because the tuple could be 3 digits. Oh my god. Does that mean I have something else missing? Don't think so. No, I kind of do, don't I? Because then this could be 2, 1. Could be 2, 1. Okay, I'm gonna stick this through because this is definitely the shortest path to any solution. But it is, I just need to think about this to get a better solution. Or I need to get a better solution than the shortest path. 1, 2, 2, all 3s. Interesting. That's definitely like a bit of recursion or dynamic programming here. Because the 1, 2, 2, or this thing leads to all the iterations of these, all 10 of them, but with a 1 in front of them. Interesting. I can somehow leverage that. Probably not. Definitely not very big brain at the moment. Okay, so I have a 2. So then the next one should be a 2, 1. And then I have 1, 2, and 3 3s left. And then like 2, 1, and then variants of this. So it'd be like 3, 2, 3, 3, 3, 3, 2, 3, 3, 3, 3, 2. And then I move the 1 further down, so it starts with 2, 2, 1, 3, 3, 3, 2, 2, 3, 1, 3, 3. And then next one up should have a 2, 3. and then a 1. But then that's after this one, actually. 2, 3, 1, 2, 3, 3. No. So it needs to start with 2, 3, 1 and then move the remaining stuff. So it'd be 3, 2, 3, 2, 3, 1, 3, 3, 2. And then I should move the 1 to become a 2. So 2, 3, 2, 1, 3, 3, 2, 3, 2, 3, 1, 3, 2, 3, 2, 3, 3, 1. And then at that point, it should be 2, 3, 3, 1, 2, 3. And then 2, 3, 3, 2, 1, 3. I'm like a little machine here. Well, I can figure out what the code would be. 2, 3, 3, 3, 1, 3, or 1, 2. I think that might be it. Yeah, 2 4s. Well, let's see how this goes. I mean, it didn't go very far in terms of the wrong answer. This is like 64th answer. 64 test case. Oh my god. 3, 1, 2, 2. Starting with 3. Oh, I'm so bad. Starting with 3. Yeah. Fine. That's fine. That is very fine. Okay, starting with 3. So it'd be 3, then a 1, then a 2 2s. 3, 1, 2, 3, 2, 3. 3, 1, 2, 3, 3, 2. 3, 1, 2, 3, 1, 3, 2, 3, 3, 3, 1, 3, 3, 2, 3, 3, 1, 3, 1, 3, 3, 3, 2. No, it's not even the correct number of 2s. What the hell? Okay, I'm going back here. 3, 1, 2, 3, 3, 2. 3, 1, 3, 2, 2, 3. 3, 1, 3, 2, 3, 2. 3, 1, 3, 3, 2, 2. Is this like counting up in terms of like I'm getting a rough way of counting this, and it feels like counting in binary in some ways. It feels like it's counting in binary for some reason. Well, there's definitely a correlation there, but I don't know. 3, so it's filled up, so it needs to have now a 3, 2, 1, 2, 3, 3, 3, 2, 1, 3, 2, 3, 3, 2, 1, 3, 3, 2, 3, 2, 2, 1, 3, 3, 3, 2, 2, 3, 1, 3, 3, 2, 2, 3, 3, 1, 3, 2, 3, 1, 2, 3, 3, 2, 3, 2, 1, 3, 3, 2, 3. Well, I missed one right there. 3, 2, 3, 1, 3, 2. 3, 2, 3, 2, 1, 3. 3, 2, 3, 3, 1, 2, 3, 2, 3, 3, 2, 1, 3, 2, 3. I think that's it. And then it needs to move on to the next one, which would be 3, 3, 1, 2, 2, 3, 3, 3, 1, 2, 3, 2, 3, 3, 1, 3, 2, 2. 3, 3, 2, 1, 2, 3, 3, 3, 2, 1, 3, 2, 3, 3, 2, 1, 3, 3, 2, 2, 1, 3, 3, 2, 2, 3, 1, 3, 3, 3, 1, 2, 2, 3, 3, 2, 1, 2, 3, 3, 3, 2, 2, 1. Okay, what did I miss now? What did I miss now? Guess I don't have that probably. Wait, what did I just do there? Three, 2, 3, 2, 3, 1. 3, 2, 3. 3, 2, 3, 2, 3, 1. Yeah, just straight up skipped it. Two, 3, 1, 3, 1, 2, 3, 2, 1. Okay. Well, that definitely is not the last one I skipped. What's another one I skipped? 3, 3, 2, 3, 2, 1, 3, 1, 2. 3, 3, 2. 3, 3, 2, 1, 2, 3, 3, 3, 2, 1, 3, 2, 3, 3, 2, 2, 3, 1. 3, 3, 2. Missing the next one being 3. Fuck. 3, 3, 2, 3, 1, 2. 3, 3, 2, 3, 2, 1. Oh, Jesus. This is so bad. What the fuck, man? 6, all 6s. And it should have been 5s and 1s. I thought I had that. Oh my god, I didn't. 5, 1, then more 5s. Well, at least that was kind of simple. And there's only so many places you can put a 1 and 5. Alright, I give up. What the fuck? Oh my god, I was really hoping this was not going to be missing. Yeah. Yeah. It is definitely missing, huh? Yeah. But it does seem like there should be some sort of recursion going on here. Does seem to be some sort recursion going on because I'm pretty sure at some point the combination of where I'm stuffing it relies on the previous level of the number of digits. Yeah, it just relies on stuffing it with the previous level of digits. It's almost like I work with the so like all the ways of combining 2s and 4s into a 6-digit thing would be inserted with a 1 somehow.